So in this video, I want to discuss about first order modified approximation of price using Macaulay and modified duration. And the first slide is actually about modified using modified duration. So we know that when we can write price as a Taylor series, I mean, we can expand the price function as a Taylor series. So we would get this nice function so forth. Our next step is actually from here we take approximation. What we do, we remove the higher order terms and just use only the first derivative. So from here, now we are ready to substitute the modified duration formula. So this is modified duration by definition. So right away, what we are going to do, we are going to, let me use a different color. We are going to replace this term using the modified duration. So you can see that modified duration time pi naught negative is going to be equal to p prime I naught. So I can replace this term in here. Okay. So when I do that, I would get pi approximately equal to pi naught minus modified duration price unit I naught I minus I naught. Now sometime you will see I minus I naught defined as delta. So this can be negative or positive, okay? Can be negative or positive or zero. Okay. So so if I use that notation, then I can write pi approximately equal to pi naught negative d mod I naught. Actually, this is what rate you are using. So I naught, pi naught, and delta. So I can take the pi naught as a common factor. Then you can see it's 1 minus delta time d mod I naught. So that's the approximation to price. This is price, no? So this is basically approximation to price using rate I naught. I mean, using modified duration. So that's the first thing we want to discuss in here. The next one we want to talk about the first order Macaulay duration. So here you can see the first order Macaulay approximation. Actually, the proof of this formula given in exam FM note provided by SOA. You can find it in D2 read this actual proof. I will go through a little bit of this one, but next one, like when you have the second order, I will just refer to the note without proving. Okay. So the beginning point of this proof, actually, we write a function. Okay. So let's actually begin from the very basic formula and then come to this one. So we know that future value equal present value time 1 plus I to t under compound interest rate model. So this idea you can write as current value is basically some constant time 1 plus I to the t. Okay, so this is basically current value. So if we set t to 0, so if t equals 0, what's going to happen? So basically, it's give you the present value. Okay. So basically, Vt is a function of single real variable. Okay. Basically, uh, it's a function of it's a function. So now what we are going to do, we are going to take the derivative of this function. Okay. So what is the derivative? So I'm going to take the derivative with respect to I. Okay. So V prime ti, which is derivative of Vti respect to di. Um, so by the way, let me set this way. Yeah, so let's do this. Okay, so I would like to set this one as I naught, the initial rate I naught. So because then we can solve for I. Anyway, I'm solve for t. Anyway, let's do this way. So what's the derivative? You have to use the product rule. So you have p prime I time 1 plus I to the t plus pi t time 1 plus I to the t minus 1. So now let's set derivative to 0. When you set this to 0, you can see that you will have p prime I 1 plus I to the t plus pi t 1 plus I to the t is 0. We can solve this for t. When I solve this one for t, what do I get? I would get t equal plus negative. So I'm taking this term to the other side. So I have p prime I 1 plus I to the t divide by pi 1 plus I to the t because I'm solving for t. Here it's going to be t minus 1. Okay. So this one give me what? This one gave me t equal negative p prime I over pi time 1 plus 1 plus I. Okay. Now let's just use the initial rate. So let I naught denote the initial rate. Okay, so because I want to show that what happened when I naught go from um, I naught plus delta or I naught minus delta. Okay, so what's the scenario? Okay, so we won't talk about new rate. This is our new rate. Okay, so that's why I want to distinguish between the original one and the new rate. Okay, so if we use that, then t become what? T become p prime I naught over p I naught 1 plus I naught. Okay, so this is you can see right away. This is modified duration. Okay, so I have modified duration at I naught time 1 plus I naught. So what is this? We know that the relationship between Macaulay and modified duration is this. So when you cross multiply, so it's basically d Macaulay at I naught. Okay, so we get this formula. So now what I'm going to do, I'm going to come back and expand this, the function of I using a Taylor series. Okay. So I can come back and I can write VTI is basically PI 1 plus 1 plus I time I naught. Okay. So then we can expand this function as Taylor series. So this is going to be Vi naught plus V prime I naught over 1 factorial I minus I naught plus V double prime I naught over 2 factorial I minus I naught square, so forth. Okay, so we again do the approximation. So this is approximately equal to Vi naught plus V prime I naught over 1 factorial I minus I naught. So of course, you can see that when you have T as Macquarie duration at I naught, so what this mean? So remember how we start? We start at that point. If T is that, then Vt I naught, Vt I is 0. Okay, so we know that if T equal, then Vt prime I naught is 0. Okay, so this term goes to 0. So I can simplify this more. So which is basically equal to what? Which is basically equal to Pi naught using this formula. You have Vi naught 1 plus I naught to D max I naught. Okay. Now I can replace the other side. So let me come back. So I can replace this term, and that would give me basically Pi 1 plus I to so now so if I just solve for Pi, remember we are solving for price. It is going to be Pi naught 1 plus I naught over 1 plus I to the Macquarie duration divided I naught. So this is the formula you see in above with the derivation. You can refer to the SOA note. It will have more clear explanation, but that's the basic idea how to get the formula. Okay, so this slide basically for to use in Excel. Okay. So when you having Excel sheet, how do you really calculate the modifier duration? So basically this one going to give you that formula. So this is one formula you need, and then this is the other formula. Okay, so again, this is for Excel calculation. Not for SOA problem. When you're having a Excel calculation, this approach can be used to calculate modifier duration. Okay, so let's try to do this problem. So read the problem and see whether you can do it. So here you can see Krishna buys NEA 1000 bond at par. The Macquarie duration is 7.959 years, giving an annual effective rate of 7.2. Calculate the estimated price of the bond using the first order modified approximation if the interest rate rises to 8.0. So let's write the first order modified approximation. It says Pi, a new price is going to be approximately equal to Pi naught minus D mod at I naught, Pi naught, and the rate in the interest rate change, I minus I naught. Okay, so now, so what are the things given? This one says Krishna buys an NEA 1000 bond at par. So basically, this means C equal 1000. So we are purchasing bond at par. So basically, price is going to be 1000. Yeah, so if you remember, if you use the discount premium discount formula, if um, since we are buying at par, it's going to be the 1,000. So you can actually check that why it's 1,000. Yeah, so basically PI note is going to be 1,000. And the modified duration we need to calculate. That's basically macro duration 7.959 divided by a rate, which is 1.072, and it's going to give you 7.4244. So I minus I naught, it's going to be 7.2 minus 8%. So that's going to be basically 0.008 as decimal, okay? Not as percentage, but as decimal, it's going to be I minus I is the other way. Let me change it. It's actually 8% minus 8% minus current rate. This is going to be 0.008. So I have everything I need, and I can substitute and get the price, new price. So PI going to be 1,000 minus 7.4244 times 1,000 times 0.008, and that is going to result 940.6. So this one would be closely 40.60. So remember, I just want to mention that a premium discount formula. So premium discount formula, it says what? It says the price minus P minus C equal C time G minus J A N J. So if G and J, so bond at par, if G equal to J, so that's going to be the price going to be the redemption amount. Okay, so if bought at par, actually bought at par means basically P equals C by the definition. Bought at par means basically yeah. Okay, so let's go next problem. In here it says Sam buys an 8-year 5,000 par bond with an annual coupon rate of 5%. Paid annually. The bond sells for 5,000. Let D1 be the macro duration just before the first coupon. Let D2 is macro duration just after the first coupon. Calculate D1 or D2. So macro duration, let's write it down. What's the formula? This is sigma T CT 1 plus I to the negative T over price. If I use I naught, it's I naught. Okay. So if I draw the timeline wise, it's a 8-year with annual coupon. So I have 0, 1, 2, 3, all the way up to 8. Annual coupon rate is 5% with 5,000. So FR is going to be 5,000 times 5%, which is going to be 250. The bond sells for 5,000. So here price is going to be 5,000. Let D1 be the macro duration just before the first coupon paid is paid. So you are standing here. So so before the first coupon, so what is the macro duration? So you can see that so it's going to be 250. The first one, time is 0. So I'm calculating this formula, okay? The numerator plus. So T is 1, T is 0 actually. Then CT is 250. Then 1 plus I naught to the 0. Plus then you have so under the new, for that person, the timeline would be like this would be 0, this would be 1, 2, all the way up. This is 7. So this one would be going to be then 1 time 250 1 plus I naught to the negative 1, so forth. The last one is T is 7 250 1 plus I naught to the negative 7. Then divide by the price. What's the price for this one? The one before it's become annuity due. So basically, you have 250% value of 250 as annuity due basically. So A. So here you can see A double dot 8 plus 5,000 V to the 7. Okay. Because you had to discount it to the by V7. Okay, so then after the first coupon, let's calculate the macro duration. So now we don't. So now we are standing. Let me use a different color. So now we are standing after the first coupon. So the first payment is going to be actually. So we don't need to consider about this one now. So the first one is actually in 250. Okay, so it's 1 for that guy again is going to be. This is going to be still 0. Then 1, 2, 7, 8. Okay, so 1 time 250. 1 plus I naught to the negative 1 all the way up to 7 times 250. 1 plus I naught to the negative 7. Okay. Then plus oh, by the way, in the previous one, I had to include the 5,000. So here I had to include so I can change this 7 time. Actually, at 7 time, you are going to get 5,250. So this should be 5,250 because you have to think about the redemption amount. Okay. So the same way when the after I have 7 time, not just 250, it's 5,250. Then divide by price. For that person, it's become annuity immediate. Okay, so you have 250. How many payments? You have 7 payments. Not the annuity symbol, it's annuity immediate. Plus 5,000 V7. So right away you can see, so when I take so this is what they call as D1. This is what they call as D2. Okay. So when I divide D1 by D2, you can see numerator is same. There is no distinction between numerator, but denominators are the one different. So when D1 divided by D2, you will get 250 A7 plus 5000 V7 divide by 250 plus 5000 V7. So basically, that's what we want to find. So now we can calculate these quantities using our calculator. So let's see what do we get. So let me use calculator. By the way, what rate we should use to discount? So since this is a par bond with annual coupon at 5%, and bought at 5,000, the yield rate is going to be same as coupon rate. Remember our formula, P minus C equal C times G minus J, A and J. So if this is same, that's 0, then G should be equal to J. So my discount rate is going to be 5%. Okay, so let's use our calculator. For A7, it's going to be N equal 7. Rate is going to be 5%. I mean, the payment is actually 250. Present value what we want. Future value is 5,000, and we get the top part. Okay, so let me do the calculation. So 250 payment, 5,000 future value, only 7, 5%, 1% value. So it's going to be 5,000. Then the other one, it's annuity immediate. I mean, the other one is annuity due, and N is 8. So let's do the calculation. So here I have 250. Before that, I need to set this one to begin. Okay, so now 5,000 for future value, 250 for payment, 8 for N, 5% for IOY, 70% value, 5,080. .79. So D1 divided by D2 would be that number. So if you use your calculator, so you get 0.9840. I mean the 41 actually, if you do. Okay, so that's how we do that problem. So here's another problem, and this one says annuity A pays 1 at the beginning of each year for 3 years. Annuity B pays 1 at the beginning of each year for 4 years. The macro duration of annuity A at the time of purchase is 0.93. Both annuities offer the same yield rate. Calculate the macro duration of annuity B at the time of purchase. So let's draw the timeline. So A look like what? 0, 1, 2, 3. At the beginning of each year for 3 years. So 1, 1, 1. Then annuity B is 4 years. the macro duration of annuity A at the time of purchase is 0.93. So, so this is going to be what? This is going to be, you can see, if I use the formula, which is sigma T CT 1 plus I to the negative T divided by price. Okay. So the price of this is annuity du. So, and then the top part 0 time 1 time 1 plus I to the negative 0 1 time 1 time 1 plus I to the negative 1 plus 2 time 1 time 1 plus I to the negative 2. For the, this is for A, and then for the B, for B it's going to be the same thing, but we have extra term. The same approach, but you can see there's going to be extra term because it has more than one. Yeah, you can see that the time to you are going to get a payment. So T time CT is 1 plus I to the 3 divide by price, which is annuity due for ending in 4. Okay, so now so we don't have the rate. So basically it says for annuity A, macro duration is 0.93. So this side I have 0.93. And let me use 1 plus I to be to negative 1 as V. So then this one I can write 1, 0, plus this one as V, this one as 2 times V square. And let me expand this annuity formula. This is what is 1 plus I to the negative 1 plus 1 plus I to the negative 2. So basically that's going to be 1 plus V square. So from here I can solve for V using quadratic formulas. So basically you multiply, so what you do, you cross multiply and you would get 0.93 times 1 plus V square equal V plus 2V square. And then from that one, you would get a formula which says 1.07 V square plus 0.07 V minus 0.93 equals 0. And then from that one, you can get the V. So using quadratic formula, V is going to be 0.9. Okay. So V is 0.9. So then you can come back and substitute that in this formula. Okay. So now you can see for the B, it's going to be 1 time V plus 2 times V square plus 3 times V cube over 1 plus V square plus V cube. And then, so this is 0.9 plus 2 times 0.9 square plus 3 times 0.9 cube. And then divide 1 plus 0.9 plus 0.9 square plus 0.9 to the 3. And then you would get the answer as 1.369. So that's the end of this video, and we will meet it again in the next video.